Title: Before the Big Bang, Are We Living in a Recycled Universe? Could it be that our universe is just one chapter in an infinite cosmic epic? A bold possibility is emerging, one that suggests the cosmos as we know it may not be the beginning, but rather, part of a grander, timeless cycle. Thanks to the James Webb Space Telescope, humanity is now gazing deeper into the fabric of space and time than ever before. What it's revealing is nothing short of revolutionary, challenging long-held beliefs about the universe's birth, growth, and destiny. Recently, astronomers using Webb spotted something extraordinary, a galaxy so ancient and massive, it shouldn't even exist according to current models. Its light has traveled over 13 billion years, a flicker from a time when the universe was still young. But this galaxy, dubbed a universe breaker, rivals the size of our Milky Way. Its existence soon after the Big Bang defies all logic. According to our understanding, there simply wasn't enough matter that early on to create such enormous structures. Galaxies were supposed to form slowly, gradually pulling together from clouds of hydrogen. And yet here it is, a fully formed giant, shining brightly in a time when the universe was barely 500 million years old. This isn't just a fluke. The James Webb Telescope has discovered more such galaxies, bursting with stars at an age when, by all accounts, stars shouldn't have existed in such abundance. Each new observation is like a cosmic puzzle piece that doesn't quite fit, and the picture it's forming is unlike anything we expected. But that's only the beginning. Another mystery troubling astronomers is the strange discrepancy in the rate at which the universe is expanding. Theoretically, using cosmic background radiation, the Hubble constant should be around 67 km per second per megaparsec. But when astronomers measure this rate using supernovae, red giants, or gravitational lenses, the number jumps to about 73. It's a mismatch that refuses to go away. And now, with Webb's unprecedented precision, this discrepancy has only grown more pronounced. So what's going on? Why doesn't our model of the universe align with what we're actually observing? Some scientists propose a radical idea: maybe our universe isn't alone. What if the Big Bang was not a unique event, but merely a ripple in a much grander ocean, a transition, not a birth? Some physicists now theorize that our universe may have merged with others during the early moments of inflation. Instead of expanding in isolation, it might have stretched and intertwined with other cosmic domains. This multiverse merging scenario suggests that the observable expansion might not be due solely to internal forces. Instead, it could be the result of multiple universes interacting, blending their boundaries and creating complex structures far beyond anything we've imagined. And this is where the theory begins to align with observation. When physicists ran the numbers under this multiverse model, something shocking happened: the predicted expansion rate closely matched our actual measurements. A theory once dismissed as wild speculation is now gaining traction. Among those championing a completely new view of the cosmos is British physicist and Nobel laureate Sir Roger Penrose. He envisions a universe that never truly begins or ends, but instead pulses in an eternal rhythm, a cosmic cycle of birth, death, and rebirth. Penrose's model, called Conformal Cyclic Cosmology, proposes that once a universe has expanded and exhausted all matter, it becomes a vast void of pure light. In this strange, massless state, time and space blur. This evidence, he says, is hidden in the cosmic microwave background, CMB, a faint glow of radiation left over from the early universe. Penrose and his team found peculiar circular patterns in this radiation, spots of temperature that seemed too regular to be random. He calls them Hawking points. The idea: at the end of the previous universe, supermassive black holes slowly evaporated through Hawking radiation. When the universe transitioned into a new one, ours, that residual energy didn't vanish. Instead, it traveled forward, leaving faint but measurable imprints in the CMB. These Hawking points, Penrose argues, are not statistical noise, but ancient fingerprints, traces of a universe that lived, died, and passed its energy on to us. Naturally, this claim is controversial. Many scientists urge caution, suggesting the patterns could be mere coincidences. But Penrose reminds us that black holes themselves were once ridiculed as absurd fantasies, and today, we photograph their shadows. Meanwhile, Webb continues to uncover even more strange truths about the early cosmos. One of its most astonishing discoveries is a galaxy known as Jade's GZ11. Seen just 330 million years after the Big Bang, it's not just old, it's bright. Too bright? Its ultraviolet light pierced through a foggy universe that, according to models, should have been nearly opaque. Why is that shocking? Because after the Big Bang, the universe was filled with neutral hydrogen, a cosmic fog that blocked light. It wasn't until several 100 million years later, during a process called Reionization, that light began to break through. Stars and galaxies emitted radiation that ionized the hydrogen, clearing the fog. But this was supposed to be a slow, staggered process. Yet Jade's GZ11 created a massive bubble of clear space, over 650,000 light-years wide. And it did so far earlier than expected. This suggests that galaxies like it played a much larger role in reionizing the universe than we thought. Or perhaps, something else entirely is going on. Where did its intense UV energy come from? Could it have been a cluster of extraordinarily hot, massive stars? Or was a voracious black hole at its center? The answers remain elusive. What's becoming clear is this: the early universe was far more dynamic and complex than we imagined. Our models may be missing key ingredients, unknown forces, dark realms, or echoes from past cycles of existence. The very rules we've built our understanding on, rules shaped by decades of theory and observation, are now being challenged. And if the evidence continues to mount, we may have to accept something astonishing, that the Big Bang was not the absolute beginning. Instead, it could have been a handoff from a previous universe, part of an eternal chain stretching far beyond anything we've dared to believe. A grand cosmic saga, in which we're just the latest verse. And the next time you look up at the stars, remember, you may be gazing at light not only from ancient galaxies, but perhaps from an age even before time as we know